All right, here's an explanation of the multiple choice questions on why the correct answer is the correct answer for the AP Classroom practice problems for circular motion that you guys did last night. The first one I'm going to go through it is number 3, and it talks about a ball swinging in a horizontal circle at the end of a string. So this is kind of like an object. The horizontal circle, it's like the surface of a table or something like that, maybe that's frictionless. And the radius is getting smaller, but this thing continues to move at the same tangential speed. Tangential speed is just this speed. So the speed is constant. It's tangent to its path at any point, so we call it tangential speed sometimes. So that remains constant while the radius gets smaller. And the question asks, what does the graph of acceleration versus time look like? So I've got acceleration and time. Well, acceleration is inversely proportional to radius. So as radius goes down, acceleration goes up. So it's going to go up, and the only one that shows it going up was option B. So option B is correct because of that relationship. Okay, the next one is this one. I think this might have been number 4 right here. It says, during an experiment, an object is placed on a disk that rotates about an axle through its center as shown in the figure. They give you the radius of the rotation of 0.10 meters, and it rotates with a constant speed of 0.60 meters per second. So it's just this object is being held on by friction. Shows you a force diagram above, but we don't know the force of friction, and they ask you what is the force of friction exerted on the object. Well, we know the friction is the unbalanced force. These two are balanced. They show us the values there. The normal force and the gravitational force are balanced. So friction is the unbalanced force. That's equal to m times the radial acceleration, but we know radial acceleration is v squared over r. So in this case, if I want to know the friction force, I've got mass times 0.60 squared times the radius of 0.1. I need to know the mass. Well, this is mg, so divide both sides by g to get your m. Divide 2 by 10, you get 0.2. So I know this is 0.2. So the answer here is 0.72 newtons. This next one, I think this is number 5. During an experiment, a block of mass 2 kilograms, 0.2 kilograms, is placed on a disk that rotates about an axle through its center again. The block is moved through different distances, a different radius from the axle, and they increase the tangential speed, which is just how fast the block is rotating. At any instant, its speed is tangent to its path, so they call that tangential speed. And they do that until the mass begins to slip. And the distance and the maximum tangential speed before slipping, Vmax, are recorded, and then you create a graph of that maximum speed squared versus r. So this is the speed squared here versus the radius, and it's a nice straight line, which you would expect it to be, because the block that's rotating, again, you've got this exact same equation we just had on the last problem, where the friction is equal to the unbalanced force, and you set the unbalanced force equal to mv squared over r for things that move in a circle. But remember that friction is equal to mu s times the normal force. And of course, in this case, the normal force and the gravitational force are equal because it's sitting on a flat surface. So I can just write this as mu s times mg equals mv squared over r, and I can cancel out the m's. Well, I've got a graph of v squared versus r, Vmax squared. So this is Vmax squared. This is r. The slope is this right here. This is Vmax. That's the slope. So if you want to calculate the coefficient of static friction, all you have to do is set mu s times g equal to the slope, which is that v squared over r. The mass is canceled out. So the answer to this, I think, was option B. Here you've got a problem where we've got an object of unknown mass going in a vertical circle at the end of a string. A measurement's made of the object's speed, tangential speed, at the bottom of the circular path, so down here. And the student has to determine the tension in the string at the bottom of the path. Which of the following measurements in conjunction with, that means in addition to the object's speed, are required to figure out the tension? So the student has the speed, but we need other information, and it tells you to pick two answers here. So if I draw a force diagram of that, I've got mg down, and I've got tension up when it's at the bottom. Tension being pointing towards the center and being longer than mg, so that there's an unbalanced force pointed towards the center. So tension minus mg is equal to ma, which is equal to mv squared over r. So if I want to calculate tension, it's equal to mg plus mv squared over r. So I not only need to know the speed of the object, but I also need to know, so I know the speed, I also need to know the mass, and I need to know the radius. Well, the choices they give me are mass and diameter. If I know the diameter, I can solve for radius by dividing by 2. So if I know those two things, I can answer it. So the answers were B and C. Last problem, number 9, I think this is. So number 9, the 100-kilogram cart goes around the inside vertical loop of a roller coaster. So it's one of these problems where you got a cart, inside vertical loop. The radius of the loop is 3 meters. And the cart is moving at 6 meters per second. At the top, the force exerted by the track on the cart at the top is, well, let's draw a force diagram. Force diagram, when the cart's at the top, we know the gravitational force always points down, but I also know that there's a normal force that always is perpendicular to the surface of the track, and that's going to be pointing down in this case towards the center of the circle. So the unbalanced force is the sum of those two. They both point in the same direction. And that's v squared over r again. If I want to calculate the normal force, it's mv squared over r minus mg. All right. I've got all this information. So the normal force is the mass, 100, times 6 squared over 3 minus 100 times 10. When you do that math, you get 200 newtons. So that answer is A. Hope that helps, guys, and good luck tomorrow on your quiz. I'll see you a little after 9 o'clock. Okay, 9:10-ish.